Welcome students to my YouTube channel. Now we are in the session 21 of third semester BSc Physics course. In this session, we are going to derive an expression for electric field on the surface of a charged conductor. In this session, we are going to derive the expression for electric field on the surface of a charged conductor. Now let us consider a conductor of some arbitrary shape. Let this conductor be given a positive charge. Now let us consider a point C. Let C be a point on the surface of this conductor. Surface of this conductor. Now consider a point C just on the surface of this conductor. Now sigma be the local surface charge density. Surface charge density. If delta S is the surface area of the entire surface, the surface area of this conductor, then the charge enclosed by the surface is equal to sigma into delta S. Now apply Gauss theorem. According to Gauss theorem, we know that the total flux emerging from the surface of this charged conductor, phi total, is equal to 1 over epsilon naught times the charge enclosed by the surface. Already we have found the charge enclosed by the surface, that is equal to sigma into delta S. Call this as equation 1. Now the Gaussian surface, this surface, to find the total flux, first let us evaluate the flux emerging locally at point C. For that one, let us imagine a cylinder CD as the Gaussian surface. Let CD be the cylindrical Gaussian surface. Cylindrical Gaussian surface which encloses the point C. So let us draw the Gaussian surface. Let the Gaussian surface be in the form of a pillbox. Now, this cylindrical Gaussian surface has three surfaces. The surface S1, for which both electric field vector and the normal are in the same direction. The second surface S2 and the third surface S3. Therefore, this Gaussian surface has three surfaces. The Gaussian surface has three faces having surfaces S1, S2 and S3. Therefore, the total flux emerging out of this Gaussian surface is equal to the flux emerging out of the first surface plus flux emerging out of the second surface plus flux emerging out of the third surface. So we have to evaluate the flux that are emerging from the three surfaces to find the total flux. Now, the flux emerging out of the surface S1 is phi of S1 is equal to surface integral of E bar dot ds bar. This is equal to surface integral of E ds cos theta. But for the surface S1, the normal and the electric field are in the same direction. So the angle theta is equal to 0 or cos 0 is equal to 1. Therefore, phi of S1, the flux from the surface S1 is equal to E, take it outside, surface integral of ds. This is equal to E into the total surface area of the charged conductor is delta S. Call this as equation 2. Sorry, 3. Call this as 2. This as 3. Now, consider the second surface. This surface S2 is inside the conductor. Therefore, the flux emerging out of the surface S2 is 0. The flux through the surface S2 is equal to 0 since the surface S2 is inside the conductor. Now, the flux emerging out of surface S3. Let us find out this one. Surface phi of S3 is equal to surface integral of S3 E bar dot ds bar. This is equal to surface integral of E ds cos theta. But in this case, the normal drawn to this surface is perpendicular to the electric field. Therefore, theta in this case is equal to 90. Therefore, cos 90 is equal to 0. So this implies the flux through the surface S3 is equal to 0. Therefore, the total flux is equal to flux through the first surface is E delta S, flux through the second surface is equal to 0, flux through the third surface is equal to 0. So this is equal to E delta S. Call this as equation 4. Now, from equations 1 and 4, we have equation, let us recall equation 1. Equation 1 is the total flux is equal to 1 over epsilon naught times sigma into ds, where ds delta s is the total surface area. So comparing equations 1 and 4, we get E delta S is equal to 1 over epsilon naught times sigma into delta S. So delta S gets eliminated. E is equal to sigma divided by epsilon naught. This is the expression for electric field on the surface of a charged conductor.